This is your final tutorial on the chapter strings. Now the last part of the chapter is left, which just deals with how to convert strings, any string that you've been given. If you want to convert it to a primitive data type, for example int or double or float or long or byte, short, anything. So here I'm just going to be taking int because once you know one of them, the others are exactly the same. So you have string, let's name it str. String str is equal to, now it has to be a number over here since you want to convert this to an int. So this inside the string you should have a valid number, for example 40. Now say you want to convert this to an int for whatever reason in your program. Just as a side note, these questions will come in section A if they do come for predict the output, or they'll ask you to convert a string to an int or something. You rarely use these in your programs. So if you want to use this, then you want to convert to an int. You want something like int I. You want it to hold the value 40. Right now you have it in string format, but you want to convert it to an int format. So all you do is say int I is equal to integer dot parse int, and in brackets comes your string or your string name. You can either write it directly like 40, this if you know what the string value is, or the better way would be to write the variable name of the string, that's str over here. So even if you change this value to say 60, then it's still going to do it correctly. So once you do this, the program will automatically convert, this function will convert for you this string. It'll put the value of 60 or 40 into this variable int I, and then you can use it for addition or whatever you want. Now this is true for all the other primitive data types as well. Like I said, double over here. The only difference will be that of course your data type will be double over here, and your code will become double dot pass double. For long it will become long dot pass long. For float it will become float dot pass float, and so on. And also just remember that you can't say something like this. If your string is, I'm not naming it, if your string is something like 1.2 and you try to convert it to an int, it's going to throw an exception. That's not valid because an int can only have an integer. 1.2 has a decimal. But if you do double dot pass double, that'll be valid. So just remember that while converting or predicting the output. So this is for strings to int or strings to any primitive data type. Now there's a way to convert these back as well. Now you should also know that this is primitive over here on this side. All the primitive data types come, and all strings are actually objects. You could put them under objects. Don't get confused here, just learn it as it is. They're all objects. So this process that we just told you about integer.parseInt and all the double and all of them was to convert an object to a primitive data type. Now if you there's another function instead of integer.parseInt. You would have seen in many places given integer dot value of. Now in brackets comes the same thing, str. Now the difference between the two is simple. This, the first one, parseInt, will return an int value. It'll return it as an int value. Your value of will return it as an int object. That's the only difference, and honestly it doesn't really matter. You can use either of them, it comes to the same thing. But if it comes in your section as a difference, you should know this. And honestly I didn't know it until a few minutes ago. So integer.parseInt, integer value of, and same goes for double dot value of, float dot value of, all of them. So that is to convert objects to primitive. Now I'm going to erase it and tell you the opposite. If you want to convert a primitive data type to an object like a string, then there are certain methods, and you would have heard this a lot, wrapper classes. Now, since a string is an object and your integers and doubles are all primitive, so right now the conversion you're doing is primitive, and you're converting it, or you're wrapping it up into objects, which in this case is a string. So you're actually wrapping it up into an object, which is why they're called wrapper classes. Now, they're just classes which help you perform this sort of conversion from primitive data types. You wrap them up into string objects. So if a definition question comes, then you should write it that wrapper classes are those classes which contain functions that help us carry out this conversion from primitive to string objects. So now, coming to the functions, I don't think this is given in your APC book, so if you have Sumita Arora, it's at the end, it's in Appendix B. It's in front of me right now. On my book, it's 491, though it's probably changed since you have the newer edition. They've given all the wrapper classes for integer, byte, float, double, character, long, short, all of them, all the primitives. So you're converting, let's take the first example of integer to a string. That means that you have a variable, say int I is equal to, again, 40, and you want to convert this to a string which will hold this value. You want it, if you have string s, you want it to be like this. You want it to hold a string format. So the way to do this, there's actually one very simple way which doesn't involve wrapper classes at all, and that is you just say s is equal to, initialize it to just nothing, it has no character in it, and then just say s plus equal to I. It's going to just hold this value, but that's not the correct way to do it, though it works. If you're wondering what s plus equal to I is, it's just a notation for s equal to s plus I. That's easier way of writing it. So all that happens is the computer converts this I into a string implicitly. You don't have to do any explicit conversion, and so it's just added to the s, which is blank, so it becomes 40 like this. So the better way to do it is using the wrapper classes. It's very simple code which I have open here. Here I've taken int I to be 88. Now I have a string str. All I've done is integer dot toString in brackets the variable name, which is I over here. So I've just put I here. So system.out.println str, just to test it, I've printed it out, and it does indeed print out 88. So that assures you that str does have the value 88, but as a string, since it's a string data type. And just to show you the back conversion, the reverse of this, int j, which is another integer, is equal to integer dot parseInt str, and then I've just printed it. So this part just displays str, and the line above that, it's just converting I to a string by using integer to string in brackets the variable name, and int j is another variable which, by this line, it's just getting the value of str. So it's converting the str into an int, and then here we're just displaying it again. So you can see here I 88 is converted to a string which holds 88. We're displaying the string, so our input, if it works, would be 88 over here. Then you're converting that string 88 back to an integer 88, and then you're displaying it again. So over here you should get another 88 printed. So your output, if this works correctly, should be 88 88. So I'm just going to run it so you can see. There, it's not 4 of them. I ran the program once before, so that's why it's getting 4. I'll just clear it and do it again. There are 2 of them. So this, the first one, is actually a string. The second is actually an integer. Obviously, we can't see that while looking at the output, but that's what it is. So this is a very similar. We did integer dot. This was the syntax. Integer dot toString converts it to string object, and in brackets I. And again, this is true for all the others. You can do it for float or double, anything you want. So this will come in section A. If you're asked, don't use this method. You should use the wrapper class way. And it's very likely that you'll be asked what is a wrapper class. So for that, I told you a definition. You can rewind and watch it. Now in section A, there are a few more conversions. It's a very common question. They'll ask you to convert something to another data type, and it troubled us a lot. So I think some of you guys also might want to know all of them. So for primitive and string, string as in objects over here, string objects, they're always objects. This has been sorted out in the last 10 minutes of this tutorial. Use for primitive to string, you do toString, you're converting it into an object wrapper class, and for the opposite, you do value of, or you can do parse int. So that's sorted out. The only other data type that they'll ask you, which is not included in those conversions, is character. Okay, so character, and they can ask you to convert this into either an int, or they can ask you to, shouldn't draw this arrow over here, or they can ask you to convert it to a string. Now to convert to a string, there's the easy way out again. Just initialize it to nothing, double quote, not quotes, double quotes without any spaces in between, and then just do s plus c, or whatever your character variable's name is, and you'll get it. S is equal to s plus c, but that's not the way how you do it. So to convert, so the correct way to do this is actually use your primitive to string wrapper class again. Just like int and double and all, that's character dot toString. It works the same way. And I'm just going to pause it over here and actually open BlueJ and write it, and then show you the code. Okay, here it is. So char c is equal to, it's a single quote A, so it's holding the value of the alphabet A. Then string s, I've just created a new string, string s is equal to character dot toString. So converting the character to a string, and which character? That's c, that's a parameter in the brackets. And then I'm just printing s just to make sure. So from before in this program, we have the output 88, 88, and here we should, if this works, get a, just a, and that should be in a string format. There's no way to check it when you see it, but it should just display that. There, 88, 88, and a. So the last a over there is not a character, but it's actually in the string format. So that is for character to string. That's done. Now character to int. If you have a character, char c is equal to, say, 8. This is in a character format, remember that. And you want to convert it to an int, say int z. Okay, so maybe you just want to add it to a number. Say you want to do 8 into 45, 0 something. Obviously, if you do this character 8 into 4050, then you're not going to get your answer. That it'll throw an exception, because you can't actually do that. You can't multiply a character with an integer. So you have to convert this character, which holds the value of 8, into an integer first. Now just remember that you can convert an integer into either a character or a string. You can convert an integer, and remember, an integer can have a value like 8, or it can have even 8000. So just remember always that it's a character. The data type character, it can hold just one digit. So if you have 8,000, then you can't convert it to a char. You can only convert it to a string. But if you have 8, you can convert it to both. So just remember that. Now, if you have the character 8 over here, and you want to convert it to an int, so I don't know. You probably would have done it in one of your earlier chapters. ASCII codes: A to Z, small a to small z, is I think 97 to 122, something like that. Capital A to capital Z is 65 to 90. They're just codes to just to assign them, to name all of them according to numbers. So if I say which alphabet has the ASCII code 66, you'd say capital B. It's just so that the computer can process it. It can't process the characters, so it's just a easier way of dealing with characters and letters. So like these two, there's also 48 to 57, which is reserved for 0 to 9. The 10 digits over here come between 48 and 57. 48 is 0 and 57 is 9. So now if you have 8, you can see that its ASCII code will be 56 is its ASCII code. 48 is zeros. Now if you look, 56 minus 48, if you minus the two ASCII codes, you actually get 8. And the logic is pretty simple. I think you all know it. So if you minus the ASCII codes, you're going to get the value of the character. So that's all we do in this method. You can make an integer, say, I think I should rub this out and do it, or I'll actually do it in BlueJ. If I have char c, I've already initialized it before, is equal to 8, and I do int x, or let's say int ASCII so you can make out what it does, is equal to, you just have to put int in brackets, and you can put c over here, and then just say int value that holds the number 8, what you want, is equal to ASCII minus 48. 48 always, because if you get 9, then it'll be 57 minus 48. If you get a 4, then it's going to be 52 minus 48, and so on. So it's going to be adjusting itself. So 48. Now hopefully I haven't printed it. This should work. So I'm just printing it over here, the value, and I'm gonna run it now. So the 8888A you can ignore right now. That's from before the previous code, and here you can see you got an 8. So that number has been converted into, first its ASCII code, converted to ASCII. So actually the value of ASCII would be, as we calculated over there, 56, and then you're just creating a new integer and you're doing 56 minus 48. So you're just minusing ASCII codes difference, you could say, and then you're just printing it. So that's the way you do character to int. So character to int is done. Now if you want to do int to character, then I'm going to clear this up in just a little flowcharts. You'll get it pretty quickly. So for integer, we know already how to convert int to string, and then you also know how to convert string to char. String to char is, I don't think I've told you yet, but it's pretty easy. If you have a string str is equal to double quotes, say b, just one character, since the char cannot take more than one character. This means that the index is 0, the length is 1, so the first index and also the last index of the string is 0, and so you can use your char function and say char c is equal to str, that's a string, dot char 0. So what you're doing is taking the string, taking its the character at the 0th index, which is B over here, that's the first one, and you're just storing it in char C. So you've converted it already. Now you can use these two conversions to convert from int to back to char. So first convert int to string by doing integer.toString, and then convert from string to char by doing this char@. method. So that's a way to convert it. And now the only one left was string to char, which I've told you already. Just use char@ 0. And again, remember, if you're asked to convert int x, which is equal to 46, any number which is more than one digit, and you're asked to convert it to a char, then you can't really do that. It'll be an invalid question because I can only store either one of these. Either it'll store a 4 or it'll store a 6. It can't store both. So you can only convert it to a string in this case. So I think just to go over it again pretty quickly, primitive to string was all your wrapper classes. All your wrapper classes like toString. The opposite from string to primitive was either you could use value of, which returns an object, remember that, or you could use parse int, parse float, whatever you want. This gives an integer or a float or whatever data type you're handling over here. To do string to char, you use char@. To do char to string actually comes under wrapper. You could actually put this over here. It's the same as wrapper, character.toString, just like integer.toString. What else is left? Int to char is by doing first integer.toString, just add a str over here, convert it to a string first by using wrapper, and then convert the string to a char by using char@ over here, and then char to int is the ASCII method. Convert the character into its ASCII code by just putting an int in front of it, like this. So you can say int x is equal to int in brackets. This just typecasts it. I think you would have learned what typecasting is. So int, you're doing this explicitly, so you're doing this manually. The computer doesn't do it for you. You tell it to do it and then it does it. So int and then your character name, for example C. This will convert to the ASCII code and then just minus 48, because that's the ASCII code of 0. So then you'll get your value in int x. So I think that's it for this tutorial. It's a pretty long one. I think it's more than 20 minutes now. So in this we just finished off the strings chapter. If you have any doubts on any of the programs, you could email us right now or ask us anything. Conversions also we've done, which is very important for section A, so you should know these pretty well. And that's it. I think we're gonna do just one tutorial on matrices maybe. So that's it for now.